Hey guys, today we're going to be looking at right angled trigonometry in the context of sort of year 10 maths, right? Specifically, finding an angle or a side of a right angled triangle using some of the trigonometric ratios, right? Now, honestly, here I've got all you'll need to really remember in terms of the base theory, finding an angle or a side of a right angled triangle, right? I've got a couple of tips that you've probably heard before that are important to reiterate. Right, but I guess maybe we can start with the common students or pitfalls or mistakes, right? So I guess the common ones are that the students will mix up opposite, adjacent, and hypotenuse. All right, let's just sort that out. Let's just sort that out now. So it's a right angle triangle, right? So I'm going to draw a right angle, doesn't matter, and then I'm just going to draw a triangle. So I draw a right angle triangle, right? This is a right angle. Now I'm just going to draw an angle in either of the other sides. We know this is always 90 degrees, so we're not really concerned about that. We always have that information, even if it's not shown. Let's just say we've chosen this angle here, right? Theta. Now, hypotenuse is always the longest side, right? And the longest side is always the one opposite the right angle. So this is going to be the hypotenuse, right? Now, if you were to intuitively have a guess what one is opposite and what one is adjacent, opposite to me sounds further away than adjacent. Adjacent means next to, right? So the side that's adjacent or next to the angle is this one, A. Adjacent, and then opposite therefore leaves the only one left, O. Okay, notice how it would be different if, say, the angle was here, the theta was here, then this one will be opposite, but that's fine. It doesn't change any sort of working we have to do later, so that's fine. Now, students will often use the wrong ratio. Now, the best way I was taught, and I think is the best way, is SOHCAHTOA. If you can sound out SOHCAHTOA, and let's actually figure out what that means, you see SOHCAHTOA. Sine, cos, and tan, right, are the three trigonometric ratios we'll be using. So, SO, opposite over hypotenuse, or opposite hypotenuse, adjacent hypotenuse, opposite adjacent. Now, there might be a bit of a mouthful. The way you do it is you write this up on your whiteboard or just above where you do your study, right? So every time you look up, you just kind of get domed by it and you can remember it without any effort. So that sort of subliminal programming and this messaging you're constantly seeing is what you want. And even if you could do a little bit more, you could branch out a little bit more, you know, and you could just say, you know, opposite hypotenuse, and then you could do, go here, and you could do adjacent hypotenuse, or you could have these sort of three ratios, right? And then you could do SOHCAHTOA. So that's kind of really important fundamentally to remembering that. So you can use this mnemonic here, or you can have these sort of ratios here, right? So that's sort of some tactics to sort of fix or stop using the wrong ratio, right? And then and then some students will forget to use inverse trig when we find an angle, right? So for this one, we'll just go to the question. We're going to do one question of finding an angle and one question of finding a side, right? So this is kind of what we drew. Opposite is opposite the angle. Hypotenuse is the longer side, which is always opposite the 90 degrees, and then adjacent is just the one next to the angle. Cool. Right, so what are we asked to find here? Find the angle, right? So some students will actually find it handy to draw a triangle. A lot of questions you will be given a triangle to draw. Honestly, most questions, but I wanted to make it a bit more difficult and sort of practice what we just practiced, right? So in a right angled triangle, the opposite side opposite the angle theta is 7.5 centimeters, and the side adjacent is 10.2 for the theta. So we know it's a right angle triangle, right? Okay, right angle. I've done a right angle. It doesn't have to be to scale, whatever. I'm gonna make it super long just because I want to decide, and then we'll just finish the triangle. Okay. So we know this is a right angle. We know this is the hypotenuse. Now, kids might freak out. Where do I put the theta? It doesn't matter. You can put it on this side or this side. I'm just going to choose this side. So I want it. This side opposite angle theta, we know that opposite is the one furthest away. So it's going to be the one literally this one. So opposite is what? 7.5 centimeters. cm. And the adjacent, or the one adjacent meaning next to here, 10.2. 10.2 cm. Right. Any other information? We've done this. Good. We know it's right angled. We've got the both sides, and we've got to find theta. So we have to think back to our SOHCAHTOA. What is it? We've got opposite and adjacent. So TOA. So we're going to be using the tan ratio, which is this one here, tan theta equals opposite over adjacent. So the best students, so draw the triangle, will just give that blank formula outright. Just give that. Teacher sees that good, then they're using the correct ratio, and they can give you some marks, and then they substitute in, and then they're simplified here. Now, a fatal mistake I always see students doing is they will round it early to say 0.74. Do not round early, okay? Round at the very end. Why? Because if you round early, it's going to compound the because by rounding early, you're making the answer more inaccurate, right? So when we take the inverse tan in a moment, it's going to compound that inaccuracy. So to minimize that, you want to round at the end. So that's totally something I should have added actually to here. Common student mistakes, round at the end, right? Now, we're asked to find theta. We're asked to find this one, right? In simple algebra, if we want to find x, you have to get everything else that's not x to the other side, right? So this goes to our thing of people forget to use inverse trig when finding an angle. We want theta, sorry, by itself. So we need to get tan over this side. So it's like, how do we get tan over this side? We need to divide by tan, right? Or go 1 over tan like this, which in other words is tan, or is inverse tan, -1, right? This is the key index rule learned in year 9, hopefully. Hence why it's tan, the inverse tan of this, right? And then they simplify. And there we go, we've got it in degrees here. Of course, that's the kind of the classic way you can do finding an angle, right? Now, what if we're finding a side? We have to find a side, right? So let's start. So we've been given an angle and we've been given a hypotenuse. So we've been given a side of an angle. In my mind, we think, okay, what can we figure out? We've got 2 out of 3 key bits of information, so we can figure out the other side if we want it. But let's firstly draw out the triangle. So I'm just going to draw a right angle triangle like this. Can be any dimensions. Hypotenuse, the longest side, remember it's always the one opposite the 90 degrees, 12.8. cm. Angle at the base is 52 degrees. At the base is 52 degrees. 52. So what are we asked to find? The adjacent side, right? Or A. So we've got hypotenuse, and we want to find adjacent. So let's think about what trigonometric ratio. SOHCAH, CAH, right? In this case, we have hypotenuse, and we want to find adjacent. I'm going to be using the cos ratio, which is here. Cos theta equals adjacent over hypotenuse, right? TOA. So as I said, best students will sort of give that blank formula, then they'll substitute what they know, which is the angle we were given and the side we were given. We don't know A, that's totally fine. As we know, we can totally solve it because we just have one pronumeral. What do I say? We want to get everything else that's not A to the other side, right? So this 12.8 needs to go away. So we're going to be timesing by 12.8, right? There's a times here. So when you simplify, A is equal to this, A is equal to this, 7.88. Now you want to keep your answer like these decimal places, and then maybe the answer will say to 3 decimal places, and then you give it as such, but you round at the very end. So those are the 2 sort of ways you can do that for right angled triangles. So hopefully we sort of covered a couple of those student mistakes. And you have a bit of a clearer idea of how to sort of do these questions. But repetition is the best for these, and having a sort of mnemonic that you can put up on your whiteboard or right in front of your face that you see is the best way to run these ratios. All right, thanks.